Hey, here's the solutions for your second review pack of the summer. Sorry it took so long, but I was on vacation exploring the mysteries of the Upper Peninsula of Michigan. The first problem, express the side length of a square as a function of the length d of the square's diagonal. Also express the area as a function of the diagonal d. So this is actually two problems. And the first one is if we call S the side length and D is the diagonal, then there's a right triangle formed by the two sides, and the diagonal would be using Pythagorean theorem, D squared equals S squared plus S squared, which of course is 2S squared. And solving that for S equals the square root of D squared over 2, or S equals D over root 2. And rationalizing, getting the radical out of the denominator, you get root 2 d over 2. Okay? The area is much simpler. Area equals side squared, and since the side is d over root 2, just square that and you get d squared over 2. So your two answers here would be area would be d squared over 2, that's the second part, and the side would be either d over root 2, or if you remove the radical you get root 2d over 2. Okay, not so bad. The next one, they're asking for the domain of this function, 1 over 1 plus root x. To find the domain, you have to ask yourself, what things can x not be, which would make some sort of violation, for lack of a better word, some things you can't do. Okay, whoop, what happened there? Hang on a second. Sorry about that. So obviously you cannot have the square root of a negative number. You can have the square root of 0, and you cannot divide by 0. Well, this expression would never be equal to 0, because in order for it to be 0, you'd have to have a negative number as the root of x, which you can't have. So therefore, the only thing that x cannot be, it cannot be negative, it can be 0. So our domain is all x such that x is greater than or equal to 0. Okay, the range is what y can be. Well, let's look at this for a minute, okay? If x is 1, the square root of 1 is 1, so y would be 1/2. Okay, so that would seem as a fraction. As x gets bigger, this denominator gets bigger and bigger, okay, which means the fraction, the value of y, gets smaller. So I'm still at a very small fraction. So the largest, if x is as large as it could be, I'm going to have a very large denominator, okay, which means the fraction is going to get very, very close. And in calculus, we would say that it would approach but not equal 0. So the smallest y could be is just infinitely close to 0. What's the biggest that y could be? Well, let's look at it the other way. If x is 0, y could be 1, because that expression 1 plus root x would be 1 plus 0, and the value of that would be 1. What if x is a fraction? Okay? So let's say that x, for example, is a fraction. Let's just say, for argument's sake, it's 1/4. The square root of 1/4 is 1/2. 1 plus 1/2 is 3/2. This expression would be equal to 3/2. That's in the denominator, so in order to see what that's equal, let's just flip it, because dividing by a fraction is the same as multiplying by the reciprocal, so that'd be 2/3. So it would seem to me that when x is a fraction, y is still a fraction. Therefore, y is between 0 and greater than 0 and less than or equal to 1. You could also look at a calculator to graph, but I would prefer you right now to do this in an algebraic way. It requires more thinking. What symmetries does the following function have? Y equals the absolute value of x. Well, in case you don't remember, the absolute value of x is a v, okay? So it's just a v with its vertex at the origin, okay? But I'm asking for the square root of the absolute value of x. Well, the square root of absolute value of x is still going to be I could have absolute value of x won't have any negative numbers. So by graphing this, you could look and see that it's symmetric to the y-axis. You could use a test for symmetry to the y-axis, which is f of x equals f of negative x. What does that mean? Well, let's just say I put 2 in for x, or yeah, okay, let's use 4 because that'll be easier. The absolute value of 4 is 4. The square root of 4 is 2. Okay. What if I put negative 2 in for x? Well, negative 4 rather. If the absolute value of negative 4 is 4, the square root of 4 is 2. I get an equation. So therefore, this is the test, f of x equals f of negative x, for symmetry to the y-axis. Okay? Number 4, f of x equals x minus 1, g of x equals 1 over x plus 1. Find the following. Okay, the composite of f of g of x. Well, to find that, what you're going to do is you're going to stick g of x, our inside function, into wherever you see x in f of x. So I insert 1 over x plus 1 into x here, and I get 1 over x plus 1 minus 1. Now, you can simplify that and if you want, but in its raw form, this is the correct answer. Find the value of f of 2. Okay, so what you're going to do here is you're going to first stick 2 in to find f of 2. So f of 2 is 2 minus 1, or 1. Okay, and then you're going to stick 1 into the function again, and 1 minus 1 is 0. Okay, how about g of f of x? This is not f of g of x, but g of f of x. All right, so what we're going to do there is our inside function is x minus 1. We're going to stick x minus 1 into g of x wherever we see x. So I get 1 over x minus 1 plus 1. And that simplifies out to 1 over x. Okay? State the domain and range and intercepts for y. Okay, this is a tricky one. All right, so let's go to this right. Actually, 5 has 2 parts. So let's look at 5 right now. All right. Y-intercept occurs when x equals 0. So if I just put 0 in for x, what I get here is I'll get negative 1, because negative 2 to the negative 0 is negative 1, minus 1, negative 2. So the y-intercept occurs at 0, negative 2. Okay? X-intercept occurs when y equals 0. Okay? So when y equals 0, it would mean that this expression, negative 2 to negative x minus 1 equals, has to equal 0. Alright, so when I set this in, I get 1 equals negative 2 to negative x. I take the natural log of both sides, and what I get here is negative x times the natural log of negative 2 has to equal the natural log of 1. You cannot have the natural log of negative 2. It doesn't exist, so there is no x-intercept. Okay? Your domain here, what can x be? Well, check it out. Could x be negative? Sure. Could x be 0? Yeah. Could x be positive? So our domain is all real numbers. Okay. Our range is all real numbers less than negative 1. How do you know that? Well, this expression here, okay, the smallest number, if this expression, let's see what values we get for y when we choose different values of x. First of all, if x is 0, we've already determined that if x is 0, this is negative 2. What happens if x is a positive number? Well, if x is a positive number, this is actually negative 2 over, I'm sorry, this is actually negative 1 over 2 to the x. If x is a positive number, this would become a very, a fraction, okay? So what I'm saying here is a negative fraction minus a number, minus 1, is still a negative number that's less than negative 1. Now, the only other thing we have to check here is if x is a negative number. If x is a negative number, then this becomes a positive exponent. And 2 raised to a positive exponent is going to be a large number. but the negative sign makes it negative, which means that it's still going to be a negative number minus 1, so it's still going to be less than negative 1. Okay? So in short, this will never be greater than negative 1. E to the x plus 3. Okay, y-intercept. Find out when x is 0. If x is 0, then this becomes 1. 1 plus 3 is 4, so the y-intercept is 0, 4. X-intercept. That's what makes this equal to 0. This will never be equal to 0 because e is a positive number. I can never, in order for it to be 0, e to the x would have to be negative 3. That will never happen. Okay, so there is no x-intercept. Domain. X could be anything. It could be negative, it could be 0, it could be positive. Okay? The range, however, the smallest value that e to the x can ever be is 0. It cannot be 0. It can be very close to 0, but it cannot be 0. Okay? If it's very close to 0, does that make sense that I'm getting very close to 3, but not at 3? So the range is x is greater than, y is greater than 3. Okay? The Manteno problem. A lot of you did this as compounded annually, which is fine, and you got an answer of something like 45. I did this in populations. Populations generally, because people are having kids all the time throughout the year, are compounded continuously. You may not have had this in math. I'll go over it once the year starts. But we use, instead of using y0 times 1 plus your rate raised to however many years, we use e, okay? And it gives you the exact time. Most of you got this problem right. I'm not too worried about it, but I just did it as a continuously compounded problem, okay? 7, 8, and 9. Here's the four problems. 7, 8, 9, and 10, rather. Let's take the solutions one by one. 7, find the inverse. When you want to find the inverse, we're going to solve for x. Doing that, I get x equals 2y minus 1. Rewrite as x negative 1 of x equals 2x minus 1. Most of you got that right. Solve for x. The way to get x out of an exponent is to take the natural log, because this base is e of both sides. We take the natural log of both sides, and I can multiply by 2x. When I multiply by 2x, natural log of e is 1, so I get 2x equals the natural log of 10, or x equals the natural log of 10 over 2. That is not the natural log of 5, by the way. Okay? And if you want an actual value, x would be 1.15. Solution for number 9, find the inverse, verify that the composite of the inverse equals x, and both ways, f of negative 1 and f of negative 1 of f of x. That's one way of telling that you have an inverse, because basically inverses replace the x with the y. So our function is x cubed plus 3. Solving it for x, we get x equals y minus 3, the cube root of that. Replacing that with x, I get x minus 3 equals, the inverse equals x minus 3 to the 1/3 power. Here I evaluate f of negative 1, and in fact it is x. And here I evaluate f of negative 1 of f of x, and in fact it is x. So we've proved that it's the inverse. Solve for y, okay? The easiest way to solve this equation for y is, remember this base is e, so I know by the inverse property for logs that e to the quantity 2t plus 4 has to equal y. Problem solved. Done. Okay? Some of you, I don't know where you were getting the numbers from, but you had, I'm not quite sure where you got your numbers. You had like 54 or something like that. You don't know what t is here. Okay, so you can't get any numbers. T can be anything. So this is all you needed to do for that problem. Okay, and that's it. Hope you guys are enjoying your summer. If you have any questions, just feel free to email me through Edmodo. Bye.